This is Algebra 1, Lesson 7.2, solving linear systems using substitution. We have the first box on our sheets tells us the steps on how to solve them. Step number 1 tells you to solve one of the equations for one of its variables. Notice they do not get very specific here. One of the equations for one of its variables. It leaves it up to your interpretation of which one is the best one. The best one is the one that's the easiest one to do. And I'll show you an example in a second about which one's easier versus which one's harder to do. But neither one is going to be wrong. So solve one of them for one of its variables. Or another way to say that is to isolate one of the variables. Get it by itself. Step number 2 tells you to substitute the expression from step 1 into the other equation and solve for the other variable. So again, you're going to go from having multiple variables to only one kind of variable. It might show up twice or it might show up more than once, but you'll go to having only one type of variable. Step number 3 is to substitute the value from step 2 into the revised equation from step 1 and solve it. Remember, when you graph two lines on a plane, there'll be one point where they cross. That one point is the solution to the system. When you make a system, when you actually list an answer to a system, you're listing it as an ordered pair. You're listing it as x comma y. And step number 4 is to check the solution in each of the original equations. So this was the last part we did with the graph and check method. We learned how to check it already. Once you get that solution, you check it. Example number 1 says choosing an equation to solve. So we have two sets of two equations or two systems. For A, it says 6x plus y equals negative 6. For B, it says 2x minus 3y equals 10. Which equation and which variable does it look easiest to isolate or to get by itself? Thinking about what you already know about how to undo things. Remember, you know to undo addition and subtraction with subtraction and addition, and you know to undo multiplication and division with division and multiplication. So if you look at the two variables in this first equation, 6x and y, we could either move y over and then divide by 6 to get x by itself, or we can move 6x over and y is already by itself. Or for 2x and 3y, we could move 3y over and then divide by 2, or move 2x over and then divide by 3. Either way, out of all four of those scenarios, the only one that is shorter is to simply move 6x over for the first equation because there is no coefficient in front of y. You don't need to do any division to get y by itself. So it would be easiest to isolate or solve for y in equation number 1 because the variable has a coefficient of 1. Again, there is no wrong way to do it. You can get the x by itself in the first equation. You can get the x or the y by itself in the second equation. The y is just easiest in the first equation since it has a coefficient of 1. For this second set, again, use that same logic. The only variable that has 1 as its coefficient is this one right here, 1c. That means you wouldn't have to do any division for that one. All you would have to do is subtract 3d on both sides. So same logic, it would be easiest to isolate c in equation 2 because it also has a coefficient of 1, just like the first one did. Come back to that one in a second. Example number 2 says solve the linear system. Okay. So when we're solving this system, step 1, look into that box that we just copied a minute ago. Step 1 tells you to solve for one of the variables. Which variable would be easiest to isolate? Look for a coefficient of 1. Do you see it? On the second equation, you can see it in front of that x. You don't have to see it, I mean, you know it's there. There's a 2x on the first one, and there's a negative 5y, and there's a 3y on the second one. This is the only one with a coefficient of 1. So you want to get x by itself in that sense. So solve for x in equation 2 to isolate x. So in order to do that, you simply move positive 3y over to the other side by subtracting it on both sides. Now you have x is equal to negative 3y minus 1. Now what that means, in place of, step number 2 tells you, in place of x in the other equation, you're going to sub in or plug in that expression, negative 3y, right there, minus 1. So substitute negative 3y minus 1 for x in equation number 1 and solve for y. So 2x minus 5y equals negative 13 becomes 2 times now negative 3y minus 1. All that did was sub in for x. Minus 5y equals negative 13. We know to distribute, 2 times negative 3y is negative 6y. 2 times negative 1 is minus 2. So negative 6y minus 2 minus 5y equals negative 13. Combine your like terms next. Combine negative 6y and negative 5y to get negative 11y minus 2 is equal to negative 13. And then start undoing. Undo minus 2 by adding 2 to both sides. When you add 2 to each side, you get negative 11y is equal to negative 11. And then get y by itself by dividing by negative 11 on both sides. When you do that, you get y's value is 1. Now we have a new value for y. Y equals 1. That is not the end of the equation. That is not the end of solving the system. Now you take that 1 and you sub it back in place of y, because it says y equals 1. So to find the value of x, substitute 1 for y in the revised equation 2 and solve for x. So x is equal to negative 3y minus 1. Instead of y, x equals negative 3 times 1 minus 1. Multiply negative 3 times 1 and you get negative 3. Negative 3 minus 1 is negative 4. So now you have an x value to go along with the y value we had a second ago, which was 1. So you have an x and a y. You write it as x comma y, 1. I'm sorry, it's x comma y, negative 4 comma 1. Then it says to check to make sure it's a solution by subbing in negative 4, 1 into each of the original equations. So let's check this first one. 2 times x, 2 times negative 4, minus 5 times 1. So negative 8 minus 5 is equal to negative 13. That one checks out just like the bell worked. And the other one sub in again, negative 4, 1 in place of x. Negative 4 plus 3 times 1. Negative 4 plus 3 is negative 1. Negative 1 does equal negative 1. That one checks out as well. Therefore, the solution is negative 4, 1. On the back, in the space, let's solve this linear system. 2x plus 6y equals 15. The other equation says x equals 2y. Again, this one has something substantially done easy for you at the beginning. You can skip that first step in the box. But other than that, follow that box from the beginning. Get a value, plug it back in, and get another value. Take about 1 minute. I find solving systems using the substitution method simpler if instead of writing them stacked on top like this, you write them side by side with each other. 2x plus 6y, and I'm going to show you why, equals 15. The other one, x equals 2y. Again, step one tells you to isolate a variable. Notice this x is already isolated to give you x is equal to 2y. What that means is in the other equation, take 2y and in place of x, substitute it in. 2 instead of times x, 2 times 2y plus 6y equals 15. 2 times 2y we know is 4y plus 6y equals 15. When you put 4y and 6y together, you can combine those like terms and get 10y equals 15. And then you can get y by itself by dividing by 10 on both sides. Y then equals the number 5 goes into both of these. It goes into 15 three times and into 10 twice. Now we have a value for y. What that means is in place of y in the other equation, sub it back in right there. So x equals 2 instead of times y now, 3 over 2. If you multiply straight across, 2 times 3, you get 6. And then 1 times 2 would be 2. 6 divided by 2 will give you x's value, which is equal to 3. Now you have an x and you have a y. The problem is not finished. You need to write it as x comma y. A lot of students, I've seen this happen way too many times, they'll do all of this work and they'll write it in the wrong order. Write it as x comma y where you don't make a mistake. X's value is here 3 and y's value is here 3 over 2. This is a solution to your system of equations. 3 over 2. That is the solution. Okay, also on the back, let's do this one. Solve this linear system here. 3x plus y equals 5. 2x minus y equals 10. Again, write them side by side. It's probably easier to do it that way with substitution. Take about a minute on that one, see if you can take care of that one. Okay, we went a little bit longer than a minute. Remember, you can isolate any of the four variables you see. You can isolate the first x, the first y, the second x, or the second y. One of them is easier than the other three, though. This y right here is easier to isolate than the other three because its coefficient is 1. This one is almost as easy, but its coefficient is -1, which would make you have to divide by -1 at the end. So since the first one's coefficient is 1, we want to get this first y all by itself. Again, if you did not choose to get that first y by itself, you could still come up with the same answer almost as easily. You'll just have one extra step to do. So in order to get that y by itself, you got to move that 3x over to the other side. It's positive 3x, so you subtract it. Or when it goes from one side of the equation to the other, positive 3x becomes negative 3x. So y equals negative 3x, and you still have positive 5 right there. Remember, you can't put negative 3x and 5 together because one has a variable and the other does not. But at this point, we have y solved. We have y isolated all by itself. This is the value for y, or this is an expression to represent y, negative 3x plus 5. That means in place of y, we could sub in negative 3x plus 5. Now, be careful with this one because it doesn't say 2x plus y. It says 2x minus, and then our expression for y. Our expression for y is negative 3x plus 5. So there's a negative out front of that parentheses. That means -1 is right there, which means negative has to distribute to both things inside. Negative times a negative here will give us a positive 3x, and negative times a positive here will give us a -5. The rest of it will look the same, equals 10 and 2x up front. Here you can combine your like terms, 2x and 3x, to get 5x minus 5 equals 10. Then you could start undoing. You could undo -5 by adding 5 to both sides. And you'll have 5x equals 15. And then you could undo 5 times by dividing by 5 on both sides. And you'll get x's value, which is 3. Remember, doing all of that work will get you no credit on a test if you don't continue. That's just solving for one of the variables. Once you have that variable, take 3 and in place of the other equation, sub it in or plug it in or dump it in, whatever you want to call it, in place of x. So instead of y equals -3 times x, now it's y equals -3 times 3 plus 5. -3 times 3 we know is -9 plus 5. So y is equal to -4. Now we have an x and a y. So you write it as x comma y as an ordered pair. X's value we found a minute ago is 3. Y's value we just found is -4. There is a solution to your system of equations. You could check that system. You could check that solution by plugging the numbers back in to see if you get true statements. 3 times 3 is 9. 9 plus -4, which means 9 minus 4, that's 5. It works for the first equation. 2 times 3 is 6. Minus a negative means +4. 6 plus 4 equals 10. That one works out as well.